Guys, welcome back to another weather installation from your YouTube meteorologist, Josh Patterson. Okay, today I'm just gonna, basically this is just kind of a continuation of my last video. If you haven't seen that yet, go and check that out. Check that joint right out, and yeah, but we're gonna get on with this enso talk though. Basically, I'm just kind of showing you what's been going on, why, how it, I guess I'm just kind of saying it can affect things like monsoon. It can affect things like whether there's like a low pressure that comes through the northern Rockies and puts down some rare late June snow. You know what I mean? That could affect the setup of the monsoon. Or like if there's going to be any hurricanes that put moisture up into Mexico that fuel the monsoon moisture, which I have a listen. I got to go on a personal rant, or almost a personal rant right now. If we are going to base monsoon success on whether or not there was tropical storm activity enough in the Pacific, the Eastern Pacific, and I'm not talking about any specific people. I'm just saying, when I just hear it though, I hear it. I'm not naming names. I'm not saying anything. There's really no one's to blame. I'm just saying, but we cannot go about here talking about, well, El Niños kill monsoons on average, and it's not like that's a fact. It's just that they've done some studies, and they've found some drier monsoons per El Niño, but it's not a big fact. It's just kind of like, it's still almost skeptical, but per average, they've found some variation of dryness in El Nino. And I can tell you this, last year was an El Nino year. It was. Oh, it was. Okay, the issue is it was basically kind of like this summer, because it El Nino'd and then finally it died sort of in July, but it was a neutral. It was a neutral. Okay, what we need this summer, right now, if it could happen right now, that would be great. For that neutral to just go cold, super cold. It's not gonna happen. You know what I mean? There's even been some warming. So I don't know if that's why we're getting a low pressure system coming through the northern Rockies, putting down rare June snow. I don't know if that's because, it just decided, hey, we're a little El Nino again. I don't know. But basically what I'm saying is, can we then just jump ship then and just say you need El Nino, or at least you need warm waters in the Eastern Pacific to get monsoon? Like, because it's either you have El Nino and it could bust it, or you don't, and you don't have any, hurricanes to give you moisture. It's like one or the other. Pick your poison. So that's all I'm saying. It's just annoying. It's like, which one are we gonna go with? Is La Nina good for a monsoon, or is it bad? Now, of course, we've had a lot of variation in the enso. We don't have a lot of consistency in the enso, unfortunately, and people will point to all sorts of things about this, but we've had a few El Ninos now these last few years, and so it's kept things in flux. Things are just really in flux. There's no constant neutrals. There hasn't been constant neutrals in like 4 years, it feels like good constant. And I'll show you what I mean. And there's many things actually I'm trying to show you what I mean. If you watched the last video, I say that 2015 was supposed to be a record El Nino. Well, I never explained why I brought that up, and why I brought that up is because it never rained a lot that winter and that autumn, and the spring for that matter. Winter and spring, it was dry. It was actually kind of dry, and that's the only reason why, when you look at 2015's numbers, we were above average in our monsoon in 2015, because 2015 was dry, and 2016 was not bad either, though it was below average. So that was a little bit more, and that's why I say, per usual, El Nino can dry monsoons out, but not really. 2016, it was below average, so that would count, but it wasn't a bad one like last year, and like this one could be. But what I'm saying is, it's like, but I'm going to go back to that. There's no constants anymore. There's not like a constant good stream of La Nina or neutral, and I think that's really what's at stake here. We haven't had constant La Nina and neutral in I don't know when. We keep having these warm variations. Like I said, just this past week it's turning out, or whenever they are taking this, because this was updated at least this most of this update was just updated today. So crazy. But you can look and see where my cursor is. We've warmed a little bit. It's like we can't get too much of this blue. Oh no, you do that, that's a travesty, right? It's, there's always got to be some kind of yellow popping back up at the perfect time, I thought we were done with El Nino in September, August, that time frame. That's why last monsoon was a bust, because it was just a strong lean towards El Nino. It was a neutral, but it was just leaning still that way, and then finally it popped back up in like October. I'll show you this. 3 things I got to show you. So I got to show you the strength of El Nino in 2015 and 16, the inconsistency we've been seeing since then, and how it's been popping up and trying to come back ever since this spring has ended, or ever since the start of this spring. It's just been a really big topsy-turvy. But let's get on with this video. It's been 6 minutes. So basically, we're still on this enso. What this is just low-level zonal east winds. Basically, west wind anomalies. So anomaly meaning what's normal for an area in the Pacific or over the ocean. So anomalies, like analogs. Analogs are more like the past, whereas an anomaly is like what is per usual. So the past, you can still get anomaly, analog, right? An analog is what's usual, or at least what could we look at? What past historic pattern could we look at? That's an analog. An anomaly is what is going on, or what has been going on in at least the current, or at least just past current, not in the past, but just, at least just as of recently anyway. What is the anomaly? Anomaly. At least that's what I think. Somebody can jump in the comments and tell me if I'm wrong about the definition, or at least the basic idea when it comes to the word anomaly. I'm pretty sure that's what it means, though. Anomalies. So west wind anomalies, because there's usually westerlies in the same place. That usually isn't going to go anywhere. El Ninos will shift it easterly or whatnot, but that's exceptional. It's usually the default or whatever is westerly. So westerly wind anomalies are the orange shades. So the orange shades are where you're seeing a lot of westerly winds. And the easterly wind anomalies are the blue shadings. So when you get a blue shading, which is an easterly wind anomaly, that means it's coming from the east, right? So it's easterly, right? It's blowing towards the West Pacific, meaning that's usually neutral, La Nina. If you get a westerly wind, and this is the dynamics and detailing and the dynamics of El Nino. El Nino, the enso, basically this is how an El Nino / a La Nina is created. So, right, like I said, you have westerly wind anomalies that are orange color. So they blow from the west, right? They go towards South America, I believe. Someone correct me. Like I said, I'm just trying to remember all this. School has been out. I haven't been I got to get back. But basically, westerly wind anomalies being orange, meaning they're blowing from the west and pushing waters towards South America, which would, over time, if western winds got stronger, or at least were persistent, they would bring all the warm water back. We'd have an El Nino. Easterly winds come from South America and go towards the West Pacific, over there in Indonesia, in Australia, and in Japan, up in there. You know what I mean? More or less Japan. China on the coast there. It pushes all warm waters over there, where it is usually most of the time. And so that's how you get a La Nina, because it pushes all the warmth in the waters in the Eastern Pacific away. And that's what's trying to happen as of like May 16th, right? And there you see a good little batch as it goes. Where's my little cursor here? Or my homemade cursor. 16th of May, boom. We have lots of warmth here in this Nino 3/1+2 region. And you have over here a lot of warmth in this 3.4/4 region. So this is cooling, lots of cooling in this area, and lots of warming, because wind anomalies, orange, which are, right, westerlies, right? Ooh, man, check my science here, y'all. So, westerly winds, they push from the west, right? Okay, so this is where, yes, so there is westerly winds over here, but there's easterly winds over here. So when you look at an actual dynamic, the winds blow in from the east and easterlies, and then they circulate like that. The westerly winds are over here, but they're going to circulate back. If, like I said, someone who studies this stuff or has at least seen, just let me know if I'm out of my mind. And I understand this is not a classroom, but basically I'm just trying to show you guys what's going on here. This is westerly anomaly as it's in over here. This is easterly anomaly as we're getting wind going away from us here on this side of the date line. Over in South America, here's North America up here. So winds are rushing towards the west, but coming from the east, hence they're easterlies. Now, these ones are coming from the west, but they're not going to make it over here. Less we should have an El Nino, of course. But they're not, but it is coming out of the west over here. It's just kind of, and this is just kind of. But here you can see we're having a little bit of variation, and I'm guessing that's why we had this low pressure. And I can show you that we have this low pressure dropping this rare snow, and it's like it must be because it's still variating. So that's kind of annoying. Let's move on. And here we have another color scheme. So let me say that. So I'm going to show you. So this is called the upper level 200 HPA. Hectopascal is what that stands for. Hectopascal. So, it just has to do with air rising, upper level velocity potential anomalies. Now, I won't pretend to know what that means. Velocity potential anomalies, though I know what upper level is. I know what velocity is. I know what a potential is. I know what anomaly is. At least I think I know what anomaly is. Velocity, of course, it's a bunch of math. We're not going to get into that, when you talk about velocity. But eastward propagation of anomalies has at times been evident. So what are they talking about? What are they talking about when they say eastern propagation of that? Well, what they're talking about, right? Upper level. So it says, since the beginning of the period anomalous divergence. So we're talking about divergence here. Divergence is divergence means goes away from, right? If you diverge, you go away. You get out, you disperse. You leave the area, right? Divergence. And so divergence, if I'm not wrong, I believe divergence is responsible for, I would say, if you're leaving, right, divergence, and I just saw it, so I know it now. Divergence, you can see as a viewer. I'm just trying to think for myself here. Green shading. Boom. And convergence, now that I'm thinking about it, makes sense. When you converge, you go like this, right? But what does a high pressure do? It's high pressure. It's going down, right? So it's converging. High pressure is dry. So you converge. Now this is a lot different with severe weather, or at least maybe the same thing applies. I forget. I'm not trying to teach you guys here, but it's interesting. So convergence, brown shading. So here you have divergence, and this is what I said. This is a La Nina. It's trying to set up, or at least a weak neutral towards a La Nina, and La Ninas are dry. Here in Arizona, they're dry anyway, and they're dry for Peru in the Pacific, East Pacific, right? So you have convergence here, hence a high pressure, if you will, and you have divergence here, hence a low pressure. Divergence, so it rises, it goes away. Convergence, it comes, it sinks. That's what's going on there. And you once again have your west longitude, east longitude at the bottom, your date at the top, and you have like, what is that in? That's just departure and anomaly. Those numbers just mean like, oh, how dry is, how much of the pressure is there? If you want to think about it, it's like you have a higher pressure, right? You're going higher. And in more diverges, you have a lower pressure. It's just the differences, though. You never get a negative 12. If I saw a hurricane come, negative 15 pressure, run for the hills. You ain't gonna make it. So that's not saying that it's literally like a hurricane at, a low pressure at negative 15. It's just saying the difference. There's differences. A difference from here. What is the difference, right? And here it's 15 on the plus side. What's the difference? It's not saying that there's a high pressure with, Like, I don't know how that would go. 15 would still be low for a freaking hurricane. Like 50 millibars, 15 millibars. We talk about 898 millibars or 900, like 9. We talk about 950 millibar hurricane to be a really strong storm. If you had 15 millibars, it would destroy everything. Negative 15 probably won't even be a difference. So that's why it makes sense, right? These aren't talking about necessarily the strict pressure. This is just the difference. And so there's a negative difference. That means it's, any kind of a, if you will, a quasi, it's not pressure, it's just, it's difference in, like you said, the velocity. It's difference in the upper levels. That's all it's about. If it was pressure, like I said, that would be like saying a storm was going to destroy everything with a millibar of those numbers. And this is long wave. I'm not going to get into it. Basically, I'm pretty sure, drier than average conditions, orange. Wetter than average, blue. There we go. Sorry if I bored you out. I'm just going to skip through a lot of this. We can explain this other times. This is basically when it's orange, it's El Nino. When it's blue, it's La Nina. Here's what I was talking about. Let's get to this real quick. So, here 2008, and I was 9 years old this year. You have La Nina, and you have neutral. Now, it's not always about was it consistent. It's did we have La Nina. And I love La Ninas for monsoons. I love La Ninas for monsoons. I love neutrals for monsoons. See? So you had La Nina, neutral. You had this little bit. So you had a little more neutral. You had this little bit of El Nino. And then RAR. More neutral. La Nina. A little bit of, neutral. And then La Nina. And then neutral, king neutral. And those were the good days. Where have the good days gone? And then you had big old El Nino that actually didn't look like an El Nino. It didn't even do what an El Nino was supposed to do. None of this year, except for maybe the monsoon, which is weird, right, was rainy. But in an El Nino, that's exactly the opposite should be happening. The winter should be rainy and the monsoon should be more or less a drag. But it was actually quite all right when we got out here with these monsoons. And then even here, you had El Nino, right? And it's like, oh, it looks like a bad monsoon, but look at that. Couldn't even get to like August before there was a La Nina kicking butt. There was a negative in JJA, which is mainly in June and July. You know what I mean? And so then that was all right. But but the variation starts. You got El Nino, neutral, La Nina, neutral, La Nina. So here was a time where we were actually all right. 2017 was still below average. It's been below average all these years. I'm counting 2020 because I have no hope for it. Basically, so much variation. And then don't even get me started with the variation. 2018 was alright, but it was below average. El Nino, neutral. La Nina, neutral, La Nina. So you think that was alright because you looked up here. Well, there's just not a lot of consistency down here. Where my cursor pencil thingy is, those are two different worlds, man. There's so much variation this way. The atmosphere doesn't really respond. So you got neutral La Nina, neutral La Nina, neutral El Nino. But then now it's messing our monsoon up. See, now it is. And it just can't get away, it seems. It seems like it just can't get away. And let's go and quickly look at what it's trying to say. So, you got, this is just probability of what likely to, so it says neutrals likely to continue through the summer, may go La Nina in the autumn/winter, we'll see, may just stay neutral. It's showing that, we have some chance, but lo and behold, there's the red increasing. But no, it looks like a good neutral brigade, so we're going to see what happens going forward. It looks like maybe this is going to have to be another 2010, 2011, 12 kind of thing, where it's a ton of neutral in La Nina. We'll see. Here's the Pacific model outlook. Man, I'm going to have to do another video. This is getting long in the tooth. Okay, so here is basically what's going on this is a model that predicts an El Nino La Nina. Pretty straightforward. So there you got your months on the bottom. You got your SST anomaly temperature in degrees Celsius. Celsius basically is just another way of looking at the temperature. You'd think that things were colder. If you had a mind for Fahrenheit and you looked at Celsius, you'd think, oh my gosh, why is it freezing? No. For whatever reason, there's like a a gap of about like 35 plus degree difference. So if you have like a 100 and like if you had a 122 degree temperature, like literally it's like a 60 degree difference. So it's like you'd have like 55 degrees in Celsius with 120 degrees in Fahrenheit. So it's weird that way. But basically that's what's going on with. You didn't need to know the Celsius part, but I'm trying to teach y'all. Okay, I'll admit it. This is a teaching session, and it's fun. Don't you agree? But yeah, this is just basically showing, like, this is basically where we are observed. This is what we have seen so far, and in this line, right? This line right here, for whatever reason, I don't know why it's so specific like that, is where all the color starts. So this is the forecast, and then this is essentially where we're at right now. And the blue line is your CPC, so Climate Prediction Center console. The red is your, what is that, DVN? Sorry guys, I'm not gonna make it. So DVN average, and then green is your statistical average. Okay, so cool. That's what those all mean. And yeah, and it looks like the blue is going the lowest. We will see what happens. Really, these don't really show that strong of a La Nina, but it's a La Nina nonetheless. At least the red and the blue indicate that. Because as you can see, let me just show you this. To be a La Nina, you have to have temperature, sea surface temperatures, negative 0.5 down. And then same thing with La Nina, 0.5 or just about and up. Anyway, guys, this is getting long in the tooth. This is part 2 of whatever I was doing last the last video. And yeah, hope you guys enjoyed it. Hope you guys learned something. And hopefully it wasn't too just, wordy. I just like giving all the weather and science stuff out there. I'm trying to get better. I ain't nowhere near where I need to be. God willing, I will work my tail off, right? Gotta do what I gotta do. But this is just so interesting to me, and I just like sharing it. But this is really mainly what I'm feeling about this whole monsoon thing. It's just really going in depth. But basically, I'm just showing you what's going on so we can understand why Arizona Monsoon 2020 may suck or may not. And we're just gonna. I just want you guys to understand where I'm at, so you'll have no more questions really. Too, like, well, how does he know that? Well, we're gonna. I just and it's not really about like debating it, but it's just interesting stuff, guys. Anyway. I hope you guys enjoyed. Come back with another video. Get along here. Peace out. Hope you guys enjoyed.